Welcome to Dollars and Data. Today we examine an SSIS framework with the hope that its features and design principles can guide your own SSIS development efforts. On the left, it's fair to set some expectations as part of a preface. First, this framework does not use BIML. BIML can be very helpful, but the need for that Gatling gun is relatively rare, and it can be difficult, largely due to BIML's script. The results you arrive at with BIML are very different from those of this framework. Next, you'll find this framework does not rely on staging tables and incessant calls to T-SQL statements. Instead, it stresses ETL over ELT and can process many millions of rows in scant minutes, and within a resource-starved VM. It has a master package that is synchronous by default and calls a series of child packages that pass their value-added payload to the next package in line for further processing. Among many other things, it also has a table-driven rules engine that dictates file processing logic and avoids having to open up packages or update if-then-else or case T-SQL logic. Ironically, our focus won't be on logging, which is a hallmark of ETL frameworks. In fact, you'll see that arguably the most popular framework on Informatica's marketplace, quote-unquote, captures operational metadata such as record count, error count, and job runtimes, all of which are then said to be non-functional requirements. In contrast, the framework you're about to see performs all those tasks, but it does so by relying virtually entirely on SSIS's native logging table, its on-pipeline row sent event, and new with 2012, its SSIS catalog reports. So with that said, we'll focus on other aspects of a framework, such as modular design, standards, and shared resources that lead to consistent quality and fewer decisions having to be made by individual developers. A final confession is that this slide deck is geared to lengthy presentations with technical details. This video tries to be brief, however, so we'll be seeing references to many details that you can only guess the purpose of, such as the use of MD5 hash keys, for instance. So moving on, enough of the preface. On the right, we see that as part of our agenda, we will first take a look at our framework's design principles, and then provide screenshots illustrating how various data warehouse ETL tasks are handled. Let's look at design principles. Arguably, the primary benefit of a framework is to simplify a BI developer's life, to reduce the number of decisions they have to routinely make, and to speed up time to delivery by letting developers only deal with a subset of the complexities that exist within ETL. Here's a quick story. An SSIS contractor was asked to join a project. He was to develop an address cleansing module using Melissa data components. He had enough on his plate getting familiar with those third-party components and deciding what combination of attributes and weights led to the highest quality results. Fortunately, the framework didn't require him to juggle staging tables and T-SQL, or logging, and bad records could be diverted to a single table, not multiple tables. And a standard set of connection managers were already configured and in place. All he had to do was pick the right template from the framework library and modify its pipeline to match the contents of an incoming raw file. All the developer needs to know is the file's name. Later, we'll see an example of pre-existing controls and transforms within a typical framework template. On this screen, we simply see what you'd be faced with while modifying a pipeline. There are a lot of details that could be covered on this slide, but the one thing I'll stress is good naming conventions. This framework leverages project and package names in order to automate a number of activities. But in general, it's easy to think that every data warehouse you build on a project is the EDW within a company. In reality, there are probably 3 other teams you're not aware of that are working with Teradata and Oracle. And more to the point, what happens when the success of your first finance data mart causes sales to hire you for their data mart? Use naming conventions that don't box you into a corner, that give your efforts room to grow and don't cause namespace collisions. This is a very important consideration for TFS version control too. Over time, it's easy for namespace collisions to occur across collections, solutions, projects, and databases. Let's talk about modularity. Here we begin to see that all framework packages ultimately fall under one of four categories: extract, cleanse, conform, or load. And the load control is not shown. It will be in a second. We'll see on the next slide what activities dictate a package's classification. The framework's four package classifications are based on Ralph Kimball. You'll find this in his DW Toolkit book. Where possible, I prefer to leverage existing bodies of knowledge, such as PMBOK for that matter, rather than recreate wheels. So extract is pretty self-explanatory. Cleanse is a very column-centric task. A common action here in such a package might be to scan all string attributes and apply regex functions to them. Conform, on the other hand, is a very row-centric task. Really here the goal is to always handle duplicate rows, perform householding and the like. To work through what can be complex logic to select surviving records as well. It all depends on clean, consistent attributes, however, that occur during a cleanse task. What Ralph calls deliver, I call load, and that's also pretty self-explanatory. This classification then helps maintenance insofar as we know where to find a package that needs to be modified. If I need to update that Melissa data package, I know I should be looking for a package name that indicates it is cleansing or conforming in nature. Now, Melissa Data's components fall into both realms because of the specific problem they handle. First, they cleanse addresses, and then they go ahead and handle the deduping. My inclination would be to create two packages. One that uses their personator transforms, perhaps, to do the cleansing, and then the other with fuzzy matching golden record conforming transforms. Microservices and APIs are all the rage, in large part because they can be swapped out so easily when a better, cheaper substitute becomes available. The same concept holds true here, but it's only achievable when you decompose tasks down to a suitable grain. Back to the benefits of taxonomies, here's another story. A client formed a large ETL team. For reasons nobody could explain, they purchased both DataStage and SSIS and hired experts at each. One of the ARCs pointed out this overlap and asked, how was work going to be delegated given the redundancies? The DataStage and SSIS architects got together and agreed that one team would be responsible for extract and cleansing, the other for conforming and loading. And in this way, the framework with a capital F provided a conceptual framework, lowercase, that made the agreement very easy. Source connections and lookup tables were left to one team, while the other worried about merging rows and loading data. So moving on, when you've got a library of framework templates, here's how they get used during whiteboard sessions. Let's imagine a product dimension has to be loaded. And by the way, this presentation uses dimensions as examples, but the same philosophy goes into reusable modules for fact tables. So in any case, the product has two sources, since some products are virtual and others are physical. Separate extracts and cleansing procedures apply, but once you've standardized values for their attributes, you can merge product rows and converge all subsequent logic into a single conforming pipeline/package. Now conversely, at the bottom, we see you can shuffle the templates so that pulling from a single source provides feedbacks to multiple dimension loads. In this case, let's imagine an insurance policy member has multiple locations at which they can be contacted. Another point to make is the use of raw files. Raw files substitute here for staging tables. They are the means by which payloads are passed between packages. I'll have more to say on staging tables later, but time and resources are expended when you use them, and they create more ETL objects to juggle in version control. Years ago, I talked to Microsoft's Joachim Hammer, a fellow UF-Gator and now Principal PM Manager on the Azure SQL team. We were running through a list of ways to avoid staging tables. ADO record sets certainly wouldn't scale, so the conversation quickly turned to raw files, which carry metadata and therefore are automatically aligned with the contents of a changing pipeline. No alter table statements required. You can pause if you'd like and read these quotes. I'll say that raw files aren't a secret among SSIS aficionados, but they may be the product's most underutilized feature. Here we have another guiding principle: expect the unexpected. So obviously, refreshing data warehouses often involves tables and files. What happens if a backlog of files begins to accrue in an FTP folder we're receiving files from? What happens if the client accidentally sends us duplicates within a file, across files? The framework handles all that. It also has a cross-reference mapping table that allows us to map, and therefore standardize, codes and even recognize aliases embedded in incoming file names. We'll get to the rules engine in a bit. The logic in the appropriate framework template also handles corner cases that may be relevant to it. So here let's take a look. We've got an iPhone and an iPad, but there's no such thing as an eyeball. So what to do? And in another instance, you might have an iPad was sold, but we're being told it was sold before they existed. What to do? In another instance, an iPad was sold long ago. It shouldn't be paired with a recent dimension record. It should be aligned with dimension records from the same period, long ago. Finally, code is streamlined by not distinguishing between historical and incremental loads. Whether the data has been backlogged or not, records are processed in the sequence required. And an important note is that this framework is pretty coupled to a data warehouse model. Both assume the use of Type 2 slowly changing dimensions across the board. But oddly, that heavy burden simplifies the design and provides users with full Type 2 benefits, such as reproducing past reports for audit purposes. By default, transaction fact tables are assumed too. Ralph Kimball mentions this design in virtually all of his books, but most conversations ignore its purest form, a fact with a single amount column whose context is defined by a transaction type dimension. Along with ELT, this is worthy of a long discussion similar to EAV discussions among modelers. Do the numbers of rows increase with this design? Yes. Does a logical record span multiple rows? Yes, it can. Do you ever need to pivot them back to a more typical shape? What's the performance hit? I'll leave it up to the viewer to mull over the pros and cons, but I found that to a very high point, the benefits far outweigh the performance overhead and increases in storage. Before leaving ETL versus ELT, I'll emphasize that ELT can make total sense. There's a slew of reasons why, but here are some. Sorts can be faster with T-SQL. Now this framework is largely fine with SSIS sorts, even though they can be slow compared to SQL Server's database engine. And certain logic, not merge statements, can be handled so quickly and easily by T-SQL that it's not worth the time to think through an SSIS equivalent. And of course, dealing with niche databases and cloud services such as the Analytics Platform System, aka PDW, and SQL Data Warehouse calls for fresh, unbiased thinking. My biggest problem, though, with doing work outside SSIS is that the work doesn't get captured by the SSIS catalog, and that has big ramifications when it comes to diagnosing problems, improving performance, handling errors, logging, and everything else SSIS and a framework can help with. Another problem is that we avoid the self-documenting aspect of any graphical ETL application if we merely resort to doing everything with SQL. Can you imagine what the boss would say if he spent millions on Informatica and you did everything with PL SQL? So before you abandon the benefits of ETL, take time to really learn SSIS. Compare merge joins to the many configurations of a lookup. Learn when to apply the balanced data distributor. If you aspire to be a well-versed Microsoft BI developer, you'll want to take the time required to truly learn SSIS. The framework's templates also provide a way to temporarily change values within a pipeline, and this can be extremely handy when you want to test a code path. During unit testing, you can also redirect data flows to a bit bucket at the last second. After all, you don't want to do a truncate or delete on a final dimension or fact table. You often just want to test a code path. Speaking of code paths, look up how to dissect the data trapped with on-pipeline rows sent. I'll always remember stumbling across a function that Brian Knight published in 2006 following Project Real. It was a real eye-opener at the time. It's all been made that much easier though with 2012's SSIS catalog. Check catalog.execution.data.statistics. There's a mouthful. Catalog.execution.data.statistics. Let's move on to packages responsible for the framework's bootstrap routines. This package creates our data warehouse or data mart. I won't dwell on it too much. There are, however, a number of complexities to consider during database creation. One version of the package creates a pretty sophisticated SQL Server database, while another creates an Azure SQL database. Again, two different modules, two different types of packages to go ahead and grab off the framework library's shelf. I'd mentioned a dimensional database model that the framework expects to interact with. That database is defined with Irwin. Here we see an older version of Irwin in action, which uses macros to generate a variety of objects in addition to tables. Some of the objects created with Irwin macros are views. One set of views exclude everything but the current row in a given dimension. Another excludes any missing members inserted during a bootstrap process we'll soon see. The synonyms, on the other hand, insulate us from changes to tables' locations. This has proven very handy from time to time. Let's move on to the master package. From left to right, the master package adds a missing member to most dimensions. Whether a particular dimension gets one or not is driven by the contents of a table that we don't see right now, but a very important aspect of this entire framework being table driven. A missing member is not supplied to the date-time dimension, for instance. Some additional packages are run next that populate the date dimension. Establish a linked server, which has also proven handy now and then. The final two loops on the right are run nightly and iterate through tables that need to be processed. Whether there are or not is determined by a table that I mentioned, a rules engine with its own table, and whether the package has already produced a payload for the batch run we're focused on. Now incidentally, each of the loops shown displays message boxes with names of the entities it's processing. That's done during design time. But you wouldn't want those interactive messages echoed during a non-verbose batch run. It would simply hang the system. All that can be controlled, however, by having your script check the status of SSIS's interactive mode variable. Now we'll take a look at a sample extract package. Without relying on .NET scripts, the package determines whether it's already delivered an artifact, a raw file in other words. Perhaps the entire solution is being rerun after an error appeared and was fixed. Still, this package did its job, so it's not going to run again. Now on the other hand, if it has to run, you might then find this Dataflow Kick in. It depends on the template you selected from the framework library. This template assumes you want to grab multiple files that are all understood to be related to each other by a portion of their file name. Here's where the rules engine appears. If files dealing with the entities customer, supplier domestic, and supplier international are provided, we see that they would satisfy Rule 1. Rule 1 implies that several packages can be looped through. We're performing limited tests, however, so all but 4 packages have been turned off, so to speak. Now we move to a sample cleansing package. I'll not go through the details on this slide, but will point out that neatness counts. If you've noticed, controls and transforms have always been aligned and share the same height and width. Hopefully, the eye is not distracted by visual chaos. Furthermore, formatting becomes quick and instinctual if you avoid the mouse. As opposed to Power BI and cloud services, SSIS provides great keyboard shortcuts that radically shorten development times. Also, all design surface objects have prefixes that adhere to the naming convention promoted by Jamie Thompson years ago. And he's right. The benefit immediately becomes apparent when you analyze log data and wish you understood whether problems were caused by a dir transform versus a DCNV transform. Notice, by the way, the dir QA transform. This permits pipeline values to be easily altered during unit tests. I'd mentioned that before. Perhaps I want to change a date and see what happens. Regardless, we surely don't want to have to change that date in a table or a file if I can do so while in my integrated development environment. Now we showcase a sample Conform package. This screenshot displays how deduping is done with sorts. and how counts are generated of how many and what kind of duplicates are being encountered. Most people would make extensive use of row counts, but that requires more things, more variables, and busies up the design surface. Let's go for something that's minimalist, that's streamlined as much as possible. And when we do that by recognizing that the framework lets SSIS logging handle all counts down all code paths. If you want to create a bit bucket in order to track rows down a code path, be forewarned. A multicast used to work nicely, but not with 2012. You won't see the results of a particular code path now if you use a multicast and then take a look at what SSIS catalog captures. It has to be something a little more robust. In my case, by the way, I choose a script task. If you want to retain bad rows, quote unquote, the framework would add slightly to this design surface and direct them to a single table, no matter whether a row has 5 strings as columns or 10 integers as columns. Rows are converted to XML that can be turned back to tabular with SQL XML queries. Here's a load package, again what Kimball would call a deliver package. Here we see a control flow. SQL statements are being applied here, but against the final destination table, not a staging table. Here's the logic needed to handle type 2 loads. At the bottom right, a row count is being used to capture total record counts by day and place that high-level data into a raw file. There's lots of ways again to go ahead and capture metadata. SSIS catalog is certainly one of them, but this is a little nicety where we can go ahead and package up some high-level information, put it into a raw file, and then you'll ultimately see that that information gets bundled together as part of an archive process with the rest of any file data that was encountered. The framework co-locates, in other words, certain metadata with any file data it processes. Last but not least is our framework's cleanup routine. Here, metadata, payloads handed off between packages, and file data is all zipped and archived. Well, that's it. We've covered a lot of ground, but there's no doubt many questions that were raised, and that's fine. The goal was to provide food for thought and suggest what can be done with SSIS when using it to its fullest and decomposing problems into small modules. Thanks again for visiting Dollars and Data.